In a previous video, we saw how to raise a number to a power, or exponent. We covered cases where the exponent is a positive integer of 2 or more. The link is in the description. This time we will see how to handle other cases, including exponents of 1, 0, -1 and other negative integers, reciprocals of integers such as a half, a third, etc., rational values such as 3/2, and negative rational values such as -1/2. We will make certain assumptions in this video. First, that all values of the base and the exponent are real. It is possible to use complex numbered bases and exponents, but that will be covered in another video. Second, that the base is not 0. Using a base of 0 can be problematic, so we'll ignore it for now. Finally, that the base is not negative. This is because some exponents simplify to square roots and other roots, which don't have real values for negative bases. Combining the last two conditions, we are only handling cases where the base is strictly positive, not negative or 0. We will start by looking at a to the power 1. We can find this by taking the rules we already know and applying them to the new case. A to the power 3 is a times a times a. We can divide both sides by a. A to the power 3 divided by a is a to the power 2. Dividing by the base simply subtracts 1 from the exponent. And obviously a times a times a divided by a gives a times a. We can do the same thing again. A to the power 2 divided by a gives a to the power 1. And a times a divided by a is just a. So this tells us that a to the power 1 is a. This makes sense if you think about it. We could define a squared to be 1 multiplied by a 2 times. So a to the power 1 is 1 multiplied by a 1 time. Now we know a to the power 1, let's divide both sides by a again. A to the power 1 divided by a is a to the power 0, and a divided by a is 1. So a to the power 0 is equal to 1. Again, this makes sense. A to the 0 is 1 multiplied by a 0 times, which of course is 1. One and 0 are special bases. A to the power 0 is 1, so 1 to the power 0 is 1. A to the power 1 is a, so 1 to the power 1 is also 1. A to the power 2 is a times a, so 1 to the power 2 is 1 times 1, which is 1. Of course 1 cubed is 1 too. In fact 1 raised to any real valued power is 1. If we look at the powers of 0, then 0 to the power 1 is 0, 0 to the power 2 is 0, and 0 to the power 3 is 0. But what about 0 to the power 0? Here there's a conflict. On the one hand, 0 raised to any power is 0. On the other hand, any number raised to the power 0 is 1. In fact, 0 to the power 0 is indeterminate. This is similar to 0 divided by 0. That is why we are not allowing the base to be 0 in this video. Now we will look at negative exponents. We know that a to the 0 is 1. Let's divide both sides by a like we did before. On the left side we divide a to the 0 by a. We know this reduces the exponent by 1, so this gives us a to the minus 1. On the right side 1 divided by a is 1 over a. So this tells us that a to the minus 1 is 1 over a. We could say that a to the minus 1 is equal to 1 multiplied by a minus 1 times. But what does that mean? Well, it could mean that we do the opposite of multiplying, which is dividing. So multiplying by a minus 1 times is the same as dividing by a 1 time. Another way to think of this is to consider a cubed times a to the minus 1. When we multiply two exponentials, we add the exponents, which is 3 plus minus 1, or 2. So a squared is a cubed times a to the minus 1. But we also know that a squared is equal to a cubed times 1 over a. So again, this tells us that a to the minus 1 is equal to 1 over a. If we divide both sides of the equation by a again, this tells us that a to the minus 2 is 1 over a squared. In general, a to the minus n is equal to 1 over a to the n. What is a to the power 1/2? How do we multiply 1 by a half a time? We can look at this by setting y equal to a to a half. Then y squared is a to the half times a to the half. This is equal to a to the power of a half plus a half, which is a to the 1, or just a. Taking the square root of both sides gives y equals root a. Since we originally had y equals a to the half, this proves that a to the half is the square root of a. We can apply the same logic to prove that a to the 1/3 is the cube root of a, and a to the power of 1 over n is the nth root of a. Incidentally, if we set a to minus 1, a to the half will be the square root of minus 1, which has no real value. This is why we are not considering negative bases in this video. It is possible to have negative bases, but it is a slightly more advanced topic. What about an exponent that is a general rational number, such as 3 over 2? We can use the power to a power rule, which tells us that a to the power 3 over 2 is equal to a to the power 3, all raised to the power 1/2, or the square root of a cubed. Any rational exponent p over q is equivalent to the q root of a to the p. Finally, we will look at negative fractional powers. A to the power minus 1/2 is equal to a to the power 1/2 times minus 1. Using the power to a power rule, this is a to the power of 1/2 all raised to the power minus 1, which is 1 over a to the 1/2, or 1 over the square root of a. This can be applied to any exponent p over q. A to the minus p over q is 1 over the q root of a to the p. If you enjoyed this video, please subscribe or visit graphicmaths.com. The link is in the description below.